Good morning, children. Today we are going to the next part of our basic geometric ideas, that is about curves. Okay, so curves, when I ask you to draw a curve, you can simply draw anything like this or anything like this. These are all curves, isn't it? These are all curves. Now, in mathematics, when you say curves, it is not only lines that are like doodles. This just drawings, we call them as doodles. They are not simply doodles. Even straight lines are considered as curves. Because children, if you take a circle, a big circle, you cut a small piece from it, then that looks like a small straight line. So straight lines also we considered as curves in mathematics. Okay, so what are curves actually? Curves are the pictures as a result of doodlings. The pictures as a result of doodlings are called curves. So you know that any doodling means just drawing something. Okay, just so any doodling gives you a curve. It can even be a straight line. Now we are going to talk about simple curve. Now children, when I talk about curves, any curve, this is a curve, this is another curve, this is also a curve, this is another curve, this is also a curve. All these things are curves. Okay, they are all formed by doodlings. Now what do you mean by simple curve? Simple curve is a curve where the lines don't cross each other. That is, simple curve means no crossing of lines. No crossing of lines. Then we call it as a simple curve. For example, first one, there is no crossing. In the second case, when you see, it is crossing over here. Isn't it? That is, starting is there, ending is there, but then in the third case here there is no crossing. Here it is crossing. Here again it is crossing. All these cases it is crossing. Right? Yes. So simple curve means the curves which are not crossing. So which are the simple curves here? The ones which I have ticked. The first one is a simple curve. The third one is a simple curve. Okay. So simple curves are curves. If a curve does not cross itself, then it is not a simple curve. As simple as it is. That is, simply a line goes without going over one another. Then it is known as a simple curve. Now, what do you mean by open curve? Now, if you have a curve, it is not, see here, there is a curve, it is open here. Now there is a curve, it is open. Now if I draw something like this, that is also open curve. If I draw like this also, this is also an open curve. It is open, okay? It is open, open boxes, open things, you know. So these are also known as open curve. Then we have the closed curve. Now what do we call as the closed curve? Now for example, if you take a circle, it is closed. It is a closed curve, isn't it? Now this is 8 is also a closed curve. It is a closed curve, but it is not a simple curve. Understood? Now this picture that we have drawn, that is also a closed curve. Now this square, if I draw, that is also a closed curve. You remember I told you straight lines also are considered as curves in mathematics. So all these are closed curve. So you understood what is curves, simple curve, open curve and a closed curve. Now we'll move on to position in a figure. Okay, how do we say where a point is lying? For example, this is a circle. Okay, you can see the black line there, that is known as the boundary of the circle. Okay, and inside there is there. Now we call this yellow region as the interior of the circle. Okay, the yellow region is known as the interior because it is inside. Interior of your house. Okay, interior means inside. So this is known as interior. What is opposite of interior? It is exterior. So whatever is outside is known as exterior. Okay, so this is inside a circle. Then if a thing is on the, then what do we call? It is on the circle or on the boundary. That is a boundary. Isn't it? In your house and all, you have a wall. Your boundary is there. Once you enter, that is your house. Once you enter the gate, that is your house. Gate is your boundary, isn't it? So now if an ant is moving, you think there is an ant and an ant is or you can say a spider. A spider is there and a spider is moving. Now, where is the spider standing? The spider is standing in the exterior of the circle. If it is standing here, we call it as it is on the circle, and if it moves inside, we call it as it is inside the circle. Now, if I point a point here, I am pointing a point A here. Here I have a point B, and here I have a point C. Now, what can I say? Point A is inside in the interior. It is in the interior. Then B is on the boundary. It is on the boundary. And C is in the exterior. So anything you can say the position of a thing. In a figure, you can say it can be inside the figure, it can be on its boundary, or it can be outside it. Okay. So there are, in a closed curve, there are three parts. One is interior or inside of the curve. Second is boundary or on the curve. And third one is exterior or outside of the curve. So these are the three things. Any figure given to you. Now if I give a rough figure like this, then this part is known as the interior. This becomes the interior. Whatever is outside, this is the exterior. And if it comes on the boundary on this line, then we call it as on the boundary. Okay, or on the figure, on the curve. Clear? So this is about position. It can be inside, outside, or on it. That's all. Now, the interior of a curve together with its boundary is called its region. That is, this whole part, you can see the black color and the yellow color of the circle. That black boundary along with the yellow color, we call it as region. Okay, this whole thing is known as the region. Now, if you consider this one, wherever I have drawn these lines, this whole portion is known as the region. That whole portion, it will be known as the region. Do you get me? So this is this whole thing, we can call it as the region. I'll write it in the blue color so that you can understand. So here inside this, we call it as the region. Understood? Yes. So the interior of a curve along with its boundary is called as its region. Now we are moving on to polygons. I told you curves, it can be made up of doodles, and straight lines are also considered as curves. Now what are polygons? Polygon is a simple closed figure made up of entirely of line segments. You have to understand the words, children. It is simple. Simple means the lines should not cross each other and it should be closed. Okay, and it should be made up of entirely of line segments. There are no curves, it is only straight lines. It is made up of all straight lines. Now a polygon, when you say, it is a simple closed figure. It has to be simple. That is, lines should not cross each other. Now if I draw a straight line like this, a straight line like this, and a straight line like this, it is closed, but does it form? Sorry, if I draw like this, does this form? It is closed. Does this form a polygon? No, because it is not simple. Here it is crossing each other. It has to be simple. What we learned, you should remember, it has to be simple, it has to be closed, and it has to be made up of line segments. Now suppose, children, if you take only one line segment, can you form a closed figure? No, we cannot. If you take two line segments, you see, however you keep two line segments, can you make it into a closed figure? Can you make it into closed figure? You keep it together. Can you make it into closed figure? No. So making a closed figure, you need minimum 3 line segment. So using 3 line segments, what figure can you form? You can form a triangle. So the smallest polygon that can be formed using line segments, it is because it has to be closed. So smallest polygon that can be formed using line segment, it is smallest polygon is a triangle, 3-sided figure, that is a triangle. Now let us see triangle. Now we can name this triangle as, I am going to name it as A, B and C. When I am naming this triangle as ABC, I can either name it this way ABC, or I can name it, I have named it as A here, then B here and C here. I can call it as ABC or I can call it as ACB. Both the names are correct. Okay. Now there are sides. How many sides, how many straight lines are there? First one, you learned about line segments. So you tell me how many straight lines are there? There is AB. AB is a straight line here. Line segment AB is there. Then you have line segment AC. Then you have line segment CB, or you can call it as BC. Anyway, three line segments are there. 1, 2 and 3. Can you see the line segments? Do you want me to draw the line segment here? This is one line segment. This is BC or CB, the line segment, and this is a third line segment. So three sides are there. These line segments form the sides of the triangle. There are three sides of the triangle. And there are three corners for the triangle. What are the corners? A, B and C. A, B and C are the three corners of the triangle. They are known as vertices. They are known as vertices. Now let us see. This is one polygon made up of straight lines. Another polygon. Can you see how many sides are there? How many sides are there? Just tick and find out the number of sides. How many sides are there, children, over here? You can see this is one side, another side 2, 3, 4, 5. 5 sides are there. How many corners are there? One corner, second corner, third corner, fourth corner and fifth corner. 5 corners are there. 5 corners or 5 vertices. Understood? So polygon has got sides and vertices. You can see here another figure. Can you count the number of sides and number of vertices? Yes, it has got 6 sides and 6 vertices. You can count and see. So sides, vertices, and there is something more to it. It is known as the diagonal. You understood what are the vertices and you understood what are the sides. Now we have to see what do you mean by diagonal. Let us look into this diagonal, children. See the figure, the last figure that I told you. Now I am going to name it. Whenever we name it, children, we go it clockwise. Clockwise means how the clock goes. Either we go it clockwise or we go it, this is what we call as clockwise. Starting from here going this way, it is clockwise, or we go from anti-clockwise. That is starting from here opposite direction, it is known as anti-clockwise. That is, for example, when you are naming this triangle, you can name it clockwise. Starting from here, I name it as A, I name it this as B and then as C. So I am naming it clockwise, A, B and C. Or I can name it as A, B and C. That is what we call it as anti-clockwise. Okay. Anyway, but it has to be in order, either in clockwise or in anti-clockwise. So now I am going to start from here. I'll start from this point A, B, C, D, E and F. Now can you see the sides? What are the sides here? Sides are AB, BC, CD, DE and EF. They are the sides of the triangle. Now when you say about vertices, what are the vertices of this triangle? Vertices, we have named it as A, B, C, D, E and F. We have named it as A, B, C, D, E and F. Now the last word, that is the diagonal. Now what do you mean by diagonal, children? Diagonal means you take any one vertex. Suppose I am taking the vertex C. From the vertex to the opposite side, you draw a line joining the opposite side. Let us see. See, F is on the opposite side, so I have drawn a line. I have connected it. Now, this CF is a diagonal. So, one diagonal is CF. Can you see? You can mark it as line segment CF. CF is a diagonal. Then from C to any other point can you draw? You can draw to A, to the point A. Join C and A. Then what do you get? you get another diagonal. That another diagonal we call it as CA. Okay, another diagonal is CA. Now from C, is there any other point to which we can connect? Yes, we can connect it to E. Now if I connect it to E, I get CE. Do you see? So CE is also another diagonal. So from one single point, I got 3 diagonals. Now, can I connect C and B? C and B is already connected. There is no new line to be drawn. Okay. It is only to the opposite side that we can. It is already connected. So it is not a diagonal. It is a side. CB is a side. Can you see here? CB is a side. Similarly, CD is also a side. It is not the diagonal. Diagonal is when those points are not connected and then we join it, it becomes the diagonal. Now suppose I am starting from point D. I am starting from point D and let me change the color to green. From point D, if I draw the diagonals, what are the possible diagonals I can have? From D, I can join A. Now let me draw and join D and A. Sorry. I've joined D and A. Similarly, can you join D and F? Yes, you should be able to join D and F as well. So if you join D and F, you will get another diagonal. So you can join like this diagonals and then you can form different diagonals. How many diagonals will be formed in this picture? Draw it and find out and tell me in the next class. Okay. Now we'll move on to the next point, that is angles. When it comes to angles, children, angles are formed when two rays meet each other. Now for example, I have a ray here. You have already learned about rays. So this point I am naming it as O and this point as A. This is ray OA. I am naming it as ray OA. Okay. And then I have another ray coming here. This ray I'll name it as OP. So ray OA and ray OP has the same starting point, that is O. These two join together, okay, at O. Now this what is formed is known as the angle. This is what we call as the angle. The angle we name it as angle POA, or we can name it as angle AOP. That is starting from A O P, or starting from P O A. Okay, either way you name, O will come in the middle. Can you see? O is coming in the middle. Any way you name it, O should come in the middle because the angle is formed at A. O. Angle is formed at O. Therefore, O should come in the middle. Understood? This is how you name an angle. So, angle is made up of two rays starting from a common endpoint. Here the common endpoint is O. The two rays forming the angle are called the arms or sides of the angle. So this OP, what we call as OP, this OP, O and P, this is known as one arm of the angle, or we call it as side of the angle. Similarly, you have OA. We call OA as the arm of the angle or as the side of the angle. OA or OP. They are known as the arms of the angles or the sides of the angles. Okay. So you understood what is an angle is, how it is formed, and how do you name an angle. And the common endpoint is called as the vertex of the angle. In this case, what is the common endpoint? O. So here what will be the vertex? O is the vertex of the angle. O is the vertex of the angle. So this much we have got it. Now next is about triangles. Triangle I have already told, triangle has got three sides. It has got three angles and all those things. So it's a three-sided polygon. It is the polygon with least number of sides. All this I have told you already. Now the question is, identify the three triangles in the figure. So here you are given a figure here. A figure is given here. You have to identify the three triangles in the figure. Now let us identify the three triangles. The first triangle, I'll mark it like this. This is my first triangle. What is the name of the triangle? I can name it as triangle A. Triangle, we write it as like this, A, B, C. Children, instead of writing triangle, triangle A, B, C, you can simply write it as triangle A, B, C. This symbol if you write, it is read as triangle, triangle ABC. That is one triangle. Then let us go see where is the second triangle. Let us see the second triangle. Second triangle, I'll get it over here. I'm going to mark it like this. Can you see where I'm marking? This area where I'm shading, this forms a second triangle. What is that second triangle name? It is triangle ABC. Now we need the third triangle. From where will we get the third triangle, children? The third triangle, it is over here. Can you see the third triangle? Which is the third triangle? It is triangle ADC. If you are not able to see it clearly, let us change again. So from here, if you take it, you have here this triangle, this portion of the triangle. That is triangle. Again, we can write it as triangle ABD. So how many triangles are there? 3 triangles. We have identified all the 3 triangles. The first one is the big triangle ABC. Then we have the small triangle here, that is ADC, and the other side ABD. Write the names of the 7 angles. Now we have to find all the 7 angles. How are we going to get all the 7 angles? Angles, I told you, while writing, you should have 3 numbers. Isn't it? 3 things should be there, and the middle one will be. So let us start. The first angle, I'll name all the angles here. You see here, this is my first angle. This is my second angle. This is my third angle. This is my fourth angle. This is my fifth angle. This is my sixth angle. Now where is my seventh angle, children? Where do I have the seventh angle? They have named the 7 angles. Where is the 7 angle? Yes, this big angle AB and AC. AB and AC are 2 and they are joining. So this big angle will be my 7th angle. Have you understood? So let us write the 7 angles. The first angle, B is in the middle. So let us write it as angle ABC or angle ABD. Anyway you can write angle ABC. Second angle is angle BAD. Third angle is angle CAD. You can name it as angle CAD or you can name it as angle DAC. Fourth angle is angle ADC. Fifth angle is angle ADB. Sixth angle is angle ACD, and the 7th angle we got is angle BAC. Is it clear? Now we have to name the 6 line segments. That is very easy. Line segment. First one is AB. Wherever straight lines are there, we can write it as AB. Then we have BD. Then we have BC. You can see as I write, you can see BC is there. See here, BD I took first, BD. Then I am taking this whole thing as BC. Then we have the small one here, that is DC. Then on the other side we have AC. Then we have AD. So have we completed all the 6? Yes, we have completed all the 6 line segments. Now the question is, which 2 triangles have angle B as common? Angle B, that is angle 1. Angle 1 is common for 2 triangles. Which are the 2 triangles? It is triangle ABC. The triangle names what you have written, you can see. Triangle ABC is there, triangle ABD is there. In both the cases, B is coming in between. That means they are the triangles where B is common. Triangle ABC, triangle ABD. These are the triangles. Okay. So we have picked out all these things, means you understood angles, you understood sides and all these things. Now next is about quadrilateral. You learned about polygons. This is about quadrilateral. A four-sided polygon is called a quadrilateral. Four-sided polygon. Now this is four side. Can you see the four sides? Yes, this is a rectangle. This figure again has got four sides. You don't know the name, you'll learn it later. See here, again you got four sides. So all these figures have got four sides, and this four-sided polygon. All polygon means it is made up of straight lines. So these four sides are there, and so it is known as a quadrilateral. The name is quadrilateral. Learn the spelling. In the next class, I will be asking quadrilateral. It has four sides and four angles. Quadrilateral has got four sides and four angles. What are the angles here? You can count the angles. 1, 2, 3, 4. In this case also 1, 2, 3, 4. In all the cases you got four angles and you got four sides. Now consider this. This is a quadrilateral. I am again naming it as P, Q, R, S. Now I am not going to give you the adjacent angle, sides and all those things. I am going to give you adjacent. The word is adjacent. 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 Now suppose you take the point R. Which are the sides that are connected to R? It is RQ and RS. So adjacent sides are RS and RQ. If you take the point S, then what are its adjacent sides? From this side SR, from this side it is SP. So SR and SP are the adjacent sides. It is just when you sit, when you stretch your arms on both sides, who you reach, they are known as the adjacent people. Okay. Now if you take P, if you take the point P, then who all are there adjacent? PS and PQ are adjacent sides. When you take Q, the point Q, when you take this Q, the adjacent sides will be QP and QR. That is, sitting at Q, if you stretch your hands on both sides, where and all will you reach? You will reach from Q to P and Q to R. That is how it is. QP and QR. Same way you have adjacent angles. Adjacent angles. Similarly, to adjacent R. To R, the adjacent angles are, for angle R, the adjacent angles are angle S and angle Q. So if you take angle R, these two angles S and Q are adjacent angles. Similarly, you can find for Q. If you take Q, P and R are adjacent. Now, when I take R, S and Q has become adjacent. What about P, children? P is the opposite angle. Opposite, you are very easy to find out opposite angles, isn't it? So opposite angle. What is the opposite angle? Opposite angle of R is angle P. Angle R and angle P are opposite to each other. Angle S and angle Q are opposite to each other. Do you get me? Angle S and angle Q are opposite to each other. Now, like opposite angles, there should be opposite sides as well. What do you mean by opposite sides? Opposite sides? If there is RS, the side RS is there. Side RS means this is the side RS. What is opposite to that? Opposite is the other side, that is PQ. RS and PQ. When you take PS, opposite side is PS and RQ are opposite sides. RQ or QR, anyway you can say. This is simply for your understanding. That is, adjacent means who are sitting next to you, they are adjacent, and who are opposite. Opposite and adjacent. That's all what you have to know. Now we'll move on to the last portion of this, that is circles. You've already learned about circles. This is a circle. In the circle, you have already learned about regions. This is the interior of the circle. In the first portion, I told you interior. Then you have the exterior, and this is known as the, this violet line is known as the on the circle, or it is known as the boundary of the circle, or boundary of the circle has got another name, children. The boundary is also known as circumference. I know you have already learned it in 4th standard, but still remember once again, it is known as the circumference of the circle. It is known as the circumference of the circle. Boundary of the circle is known as the circumference of the circle. Now see here, in this circle, this is a circle. The black color is the boundary of the circle. Yellow color is the region inside the circle. Now you have a point. I name that point as O. Now how do I name this circle? This is a circle with center O. This is a circle with center O. Okay. Now, if I give you, what is this? 2 points on the circle. I have taken 2 points on the circle. This is my point A and this is my point B. Now, these 2 points are joined along the center. What do we call it? AB is known as the, you know it already, AB is the diameter of the circle. AB is the diameter. AB is the diameter of the circle. Now, from the center to a point, if I draw another line from the center, starting from the center, for example, if I take it as OP. What is OP? OP is the radius of the circle. OP is the radius of the circle. You need not learn about any connection between them now. OP is the radius of the circle. Okay. Now, when OP is the radius, OA is also radius. OA is also radius. Can you see? Now, when these two radius meet, this is the center, OA is a radius and OP is a radius, then there is a region, a portion inside, like cutting out a cake piece. Can you see this? This portion, we call it as, there is a name for this portion, like a cake piece cutting, a piece of cake taking outside, that portion is known as sector. That portion is known as a sector of a circle. Here again you have another sector here, BOP. BOP, when you take, this is another sector. BOA, this full half circle, if you take, that is also another sector. Understood? This is known as sector of a circle. Now you see here, I am drawing another line, that is, I am naming it as M and N. MN has got another name. Do you know that? This is new to you. MN is the chord. Okay, we write it as CHORD, but it is read as chord. MN is known as the chord of the circle, and when you draw a chord, there is a portion that is cut out from the circle. This is known as segment of the circle. This portion is known as segment of the circle. Okay. Now, whenever there is sector or segment or anything, that is, when you cut a circle, if it is the center, and then you are cutting it like this, there is a portion of the circumference. I told you this is the boundary. This portion of the circumference, if I take it out, it will come like this. This portion, this small portion, like in a bangle, if you break a piece, how you will get? This portion is known as arc of a circle. Okay, this portion is known as arc of a circle. So we'll discuss about all these things in higher classes. Now in the next class also we'll be discussing all these things. So for the time being, I'm stopping the class. Just go through the video properly and then I'll be sending you notes. Thank you, children.